Welcome back. Now we're going to look at what happens when we lift objects, drag them, push or pull, but do it on an angle. In this case, the object is being pulled upwards this way with a 55 Newton force. I mean, there could be a person standing here dragging this sideways. And so part of that energy, part of that lifting energy, is going to be directed upwards, and part of it is going to be pulling forwards like this. So here's our construction. And I'm going to make the trigonometry very easy here because you don't need to know anything other than what I'm about to tell you. When you have a force that's acting on an angle like this, you can always break it down into two components. One is horizontal. One is horizontal, and we can call this the fx. I think that's probably the best thing to do, and call this the fy. So the fx is going to be the horizontal. Here's our angle. I'm just going to call that theta. You remember theta from your Math 1201. And this is going to be fy. This is the component of the force in the vertical direction. And so here's the overall force right there. And in this case, it's 55, but it could be anything. And here's how this works. Every single time you see a force on an angle like this, it's very simple. All you got to do is say, oh, well, this piece here is going to be F times the cosine of theta, whatever that is. And this one here, this is going to be F times the sine of theta. And it works every single time. You never need to think about it. All you need to do is look and say, oh, which component is touching the angle? This component is touching the angle. So it's the one that gets the cosine. It's not necessarily horizontal or vertical. It's touching. And this one here is not touching. So the one that's touching, and, by the way, touching is another word for adjacent, right next to. And not touching is another word for opposite. And if you remember your trig, your cosine is adjacent over hypotenuse, and your sine is opposite over hypotenuse. So this is where it comes from. And my goodness, now I have a whole bunch of notes written there. But basically, the component that's touching the angle is multiplied by cosine. The component that's not touching the angle is multiplied by sine. I'll show you how this works. So here now we have 55 newtons, and then we have a horizontal component here. There's 48 degrees. This is going to be 55 times the cosine of 48. And going up, it's going to be 55 times the sine of 48. So those values work out to be, I'm going to write them over here on my little diagram. This is going to be 55 cosine 48. And I get 36.8. So 36.8 newtons are pulling sideways. And then we have 55 sine 48, and we get 40.9. 40.9 newtons are lifting. So the 55 breaks down into, and hopefully you understand how this works now. 40.9 is going up, 36.8 is going across. If you do the Pythagorean theorem on these two sides, it'll come out to give you 55. I don't know if you've ever tried this, but you can try this with a triangle. Hey, why not? So let's try this. So if I go like that, and this side is 40.9, and this side is 36.8. Oh, that's 48 degrees. And now I'm going to do the Pythagorean theorem. So here's your F. So your F would be the square root of 40.9 squared plus 36.8 squared. And you can try this on your calculator along with me, assuming you brought one. And my calculator is the one that's on my phone that looks just like a Casio 991. So here we go. Square root of 40.9 squared plus 36.8 squared. And what a surprise. You get 55. It's 55.0 newtons. So folks, this is the cool thing about trigonometry, is that it works with the Pythagorean theorem. Everything all fits together here, right? If you use the cosine to find the horizontal component, you use the sine to find the vertical component, and lo and behold, when you do the Pythagorean theorem on it, this happens, right? You get the original number back. Very cool. So now I'm being asked, what is the normal force here? What's the normal force? Well, here's my free body diagram. 10 kilos, acting down, as always, the force of gravity is mg. Acting up, we have the normal force, that's the reactive force of the surface, but we also have now 40.9 newtons acting up. So we've now returned to the same kind of situation we had in number 1. Our acceleration is 0, and our up forces and our down forces are equal to each other because there is no acceleration. In this case, the acceleration in the vertical direction. There might be acceleration happening horizontally, but in the vertical direction, which is the free body diagram I have drawn here is in the vertical direction, there is no acceleration taking place. So my up and down forces, there's your up, there's your down. The up and down forces must be equal because this is not accelerating upwards or downwards. So here the Fn is going to be mg, which is 10 times 9.81 minus 40.9. And the normal force in this case is going to equal 98.1 minus 40.9 equals 57.2. But you know, the main thing to remember from this problem is how we broke down the components. When you have your force on an angle multiplied by the cosine of that angle, and it will give you the horizontal component. Multiply by the sine of that angle, and it will give you the vertical component. It works every time. You never have to think about it. You never have to draw a triangle. You don't actually have to do trig at all. All you got to do is just remember. Touching the angle, hey, multiply by cosine. Not touching the angle, multiply by sine. Works every time. Well, now let's take it down to number 5. So I don't know what's going on there. Get rid of that. Don't like the look. Somehow I can't get rid of it. Oh well, I guess I'll just have to tolerate it. So here now there's no friction acting, but it's being dragged on an angle, and we had to find the normal force and the acceleration. Well, the normal force, you're only going to look at what's going on vertically. Here we have, now I'm going to draw this right in here. There's a 12 Newton force acting on an angle. This will be 12 cos 38, that's the horizontal one, and this will be cos sine 38. See, I didn't even think about it. There's nothing to think about. All you got to do is, oh, that's 12, 12 cos 38, 12 sine 38, and boom, you got them. So here now in the vertical direction, we're going to have this. Acting upwards is going to be 12 sine 38, which is 7.39 newtons. Of course, we also have a normal force, which is unknown at this point, but that's what we're going to solve for. Going down, we have the force of gravity, which is mg. Oh, and it's already solved for us. The force of gravity here is 19.6 is 2 times, this is the force of gravity. This problem already has it listed. So there's 19.6. So now the normal force plus 7.39 equals 19.6. The Fn is 19.6 minus 7.39. Calculator will solve this for us. 19.6 minus 7.39, and we get 12.2. So that's the normal force. If there were friction, we would multiply. Remember, the force of friction is whatever the coefficient of friction is, it's usually kinetic, multiplied by the normal force. So if we have friction, once you have the normal force, all you do is you multiply it by the coefficient of kinetic friction, and you have the force of friction. Wow. Anyway, let's go to part B. Now we're looking for the acceleration. The acceleration is happening in the horizontal direction. So here's our free body diagram. 2.0 kilograms. This is, what did we say it was? Oh, 12 times cos 38. 9.46. 9.46 newtons. This is the 12 cos 38. That's what's pulling this way. Over here, there's nothing. We're told there's no friction. So there's nothing on the other side. There is only one force. That means that the F net is 9.46 newtons. There's nothing to subtract. The F net is MA, and the acceleration is 9.46 newtons all over the mass, which is 2 kilos. I had to come over here and do that. So that's 9.46 divided by 2 equals 4.73 meters per second squared. Like so. And I'm going to stop that one and make a third one.